right, since I have to be gone from class, I'm going to make a video of the notes here. I'm using my iPad to do it, so it might be a little awkward or whatever. But here we go. So, reference angles. Reference angles are angles where when you want to get back to the x-axis. So, for instance, if you're all the way over here, you have a certain angle. Let's say you have like 135 degrees. And a reference angle is the angle that you would use to get back to the x-axis. So that would be 45 degrees in this case. So the reference angle for 135 degrees is 45 degrees. One thing about reference angles, they're always positive. So it's just telling you basically the distance from your angle to the x-axis. So for instance, let's say, you went back around, I don't know, to here. And you went up, and where you were, let's see, that'd be 180 plus 60, 240. And so if you were at negative 240 degrees, you would say that your reference angle, this spot right here, that much would be 60 degrees because it would be the amount to get you back to the x-axis. So it's always the closest distance to the x-axis. So also, for example, like let's say you went around a full time and then up here to, let's say 60 degrees. So your reference angle would be 60 degrees, okay? All right. So let's do a few. So 600 degrees, negative 600 degrees. So negative 600 degrees, I have to go back 360. So around 360, let's see. So then I have 600, 360, so that's 240 more to go. So 180 and then 240 would be 60 more. So the reference angle for negative 600 would be 60 degrees. All right, 15 pi over 4. So when I count radians, I like to say to myself, what would be a full time around? So pi over 4, 8 pi over 4 would be a full rotation. So 16 pi over 4 would be 2 full rotations. So I can now tell that I've gone a full rotation, that's 8 pi over 4, and then it's basically 7 more. So it's all but the last pi over 4. So I can tell I'm ending up right here. So therefore my reference angle is pi over 4. Reference angles are always positive. It's just your distance back to the x-axis. So here, negative 120. So negative 120 puts me right there. And so my reference angle, this little spot to get back to the x-axis, would be 60 degrees. All right, 11 pi over 6. Well, 12 pi over 6 will be a full rotation. So 11 pi over 6 is all but 30 degrees all the way around. And you know that because it's also in the unit circle as well. So anyway, the reference angle would be pi over 6 because it would take that much to get back to the x-axis. All right, so now when we do these down here, you're going to need to think of your reference angle if you're going past a full rotation. So like for instance, number 5, it says a secant of 315 degrees. Well, 315 degrees puts you just right, let's see, 315, yeah, 45 underneath. So it's right there. So secant of 315, so I'm going to go to my unit circle. 315 is right here. It's asking for the secant. So the secant would be the reverse of the cosine. So the cosine here, remember also ASTC. The cosine is positive here, so the secant's also going to be positive. So the reverse of the cosine would be 2 over radical 2, the reciprocal. And so then I had to rationalize that into 2 radical 2 over 2, which those are 2's will cancel, so just radical 2. All right, so there we go. All right, cosecant of 2 pi over 3. So cosecant 2 pi over 3 is over here, 60 degrees is my reference angle. And 2 pi over 3, cosecant is the reverse of sine. So since it's a 60 degree angle, I know that the sine from over here is, let's see, 1/2 and radical 3 over 2. And we're in the second quadrant, so it's negative 1/2 and radical 3 over 2. So the cosecant, I'm going to flip this guy over. So it'd be 2 over radical 3, which when I rationalize it turns into 2 radical 3 over 3. All right, and cosine of negative 810. So negative 360 would be one time around. Negative 720 would be another time around. So 720, let's see, that's 90 more. So I'd have to draw this, I'd have to go around once, twice, and then 90 more. So that puts me here. So it puts me at 270, which the coordinate is 0, negative 1. And so the cosine would be the x value, the 0. All right, tangent of 16 pi over 3. Well, it would take 6 pi over 3s to get around a full time. That means 12 pi over 3 is around twice, so that means that there's 4 left. So this is around 6 pi over 3, then 12 pi over 3. So 4 pi over 3 left. So 4 pi over 3, let's see. 3 pi over 3 is a halfway. So 4 pi over 3 would put me pi over 3 past halfway. The pi over 3 is 60. So that means I have a 60-degree angle right here. So I know at 60 degrees, the coordinate, I just wrote it up here, is 1/2 and square root of 3 over 2. I'm in the second quadrant, so it's negative 1/2. I'm looking for the tangent. So it will be negative here. Remember my ASTC, the tangent here is negative. So I will be putting square root of 3 over 2 over negative 1/2. The negative 1/2 will flip up, so I will just get negative square root of 3 as my answer. All right, 11 pi over 3 down here. So 11 pi over 3, let's see, it takes 6 pi over 3 to get a full time around, 12 pi over 3 to get 2 full times around. So I'm a pi over 3 short of getting 2 full rotations here. So once around and everything but a pi over 3. So that means I must be at a 60-degree reference angle. Well, again with the 60 degrees, it's 1/2 and negative square root of 3 over 2. And I'm looking for the sign, so I will answer negative square root of 3 over 2. And the secant of 7 pi over 2. Well, secant of 7 pi over 2, let's see. So that would be the reverse of the cosine, the reciprocal of the cosine. So let's see, 4 pi over 2 would be 1 time around. 8 pi over 2 would be twice around. So this is all but 1 pi over 2 at 90 degrees from 2 full rotations. So I have 4 pi over 2, and that'd be 5, 6, 7 pi over 2s right there. So I'm at the point 0, negative 1. So secant is reverse of cosine. Cosine is the x value. So remember that 0 is made by doing 0 over 1. So if I do the reciprocal of this, I get 1 over 0, which is bad news, undefined. Okay. All right, on to the second page here. I might have a couple more. Oops. Where is that second page? There it is. All right, so here we're trying to go backwards. Here you are asked to basically solve each equation. So I'm going to try to find theta here. I want to find a theta, an angle right there, that produces a cosine of radical 2 over 2. So this is just like a backwards look at the unit circle. So it says to do this from 0 to 2 pi. So I would need to look on the unit circle and find wherever the cosine, basically the x value, is radical 2 over 2. So when I look at my unit circle, I see an x value radical 2 over 2 here. Remember ASTC, I'm going to look in the 4th quadrant because that's where the cosine is positive again. So right there. So my answers to this question are pi over 4 and 7 pi over 4. So theta must be pi over 4 and 7 pi over 4. Sorry, this is so messy. All right, so the next one, tangent is radical 3. Now this is a unit circle answer. Now remember, tangent, there's 2 yucky places for tangent. There's the place where you do radical 3 over 2 over 1/2, and there's also the place where you do 1/2 over radical 3 over 2. This guy produces radical 3. This one produces 1 over radical 3, which eventually turns into radical 3 over 3. So remember the tangent, you are taking the y value over the x value. So whenever we do the tangent of 60 degrees, we're going to get radical 3. Whenever we do the tangent of a 30 degrees, we're going to get radical 3 over 3. And so I can actually do both these problems in one foul swoop here. The tangent is radical 3. So remember my ASTC, the tangent's positive here and here. So I'm looking for a 60 degree angle in those quadrants. So the first one is 60 degrees, so pi over 3. The next one, the 60 degree angle in the 3rd quadrant, let's see, 180 would be 3 pi over 3, so I will need 4 pi over 3. And you can also look around your unit circle. I just know it, so anyway, number 14. I'm looking for tangent to be negative, so it would be in the other 2 quadrants. So I need a 60 degree angle is there. So in the 2nd quadrant, it'll be 2 pi over 3. And in the 4th quadrant, that would be 5 pi over 3. So basically here what I was looking for is I was looking for a place where the x value was, whoopsie, I got that mixed up. I'm not looking for pi over 3s, I'm looking for pi over 6s. So hang on a second. Okay, so forget what I was saying. Same thing about the second and the fourth quadrant, but I'm looking for 30 degree angles, because that's where my x is radical 3 over 2 and my y is 1/2. So I'm looking for places where that's true and where one of them is negative. So basically what I'm thinking of in my head is this. I'm looking for a place where the x value is radical 3 over 2 and the y value is 1/2. So I'm looking for right here. And I'm looking for where one of them is negative. So I want this one and I want this one. So it would be 5 pi over 6 and 11 pi over 6. All right. So, number 13, sine is negative 1/2. So, you're thinking to yourself, well, ASTC, negative, sine is negative here and here. And the sine value is the y value. So I'm looking for a place where the y value is 1/2 in these two quadrants. So that would be 30 degree angles in these quadrants. So looking back at your unit circle, that would be 7 pi over 6 and also 11 pi over 6. All right, down below, when is the sine 0? So that's nice and easy. I'm looking for a place, so it should be one of the four corners then, some place where the y value is 0. And so that's easy to see here and here. So 0 and pi. And because the question was asked in radians, I'm answering it in radians. It was asked in degrees, I would answer in degrees. All right, tangents undefined. So this must be one of the four corners because I need a place where 0 appears on the bottom or on the denominator. So therefore, I'm going to look back at my unit circle. My tangent is my y over my x, my sine over my cosine. So I'm going to look for the x value to be 0. So when I look there, the x value is 0 here and here. So at pi over 2 and 3 pi over 2. So notice, all these things repeat themselves. There's basically two places on the unit circle for the most part where angles have the same sine, cosine, or tangent, and so forth. All right, down here, so this last little part here, it says use a given point on the terminal side of an angle to find the value of the trigonometric function indicated. All right, so this one you can't use a unit circle. So what's going on here is they're giving you a point. So I'm going to draw it. This point is 2 and negative radical 5. So if I go positive 2 and down radical 5, it puts me, say, about here. So what you do is you draw a right triangle. You say to yourself, hey, I've gone over 2 and down that far. So you draw your little right triangle right here. And then the distance here is 2. And then even though the distance is positive, you've gone down, so you say negative radical 5 right there. So you have to use your Pythagorean theorem to find the other side. So remember your a squared plus b squared equals c squared. So that will be 4 plus radical 5 squared will be 5 equals c squared. So c squared equals 9. So therefore c is 3. It would be plus or minus 3, but the hypotenuse is always positive. So 3 here. So now that you know these three sides, okay, I'm going to erase that other one. It looks a little gross. All right, now that you know these three sides, you can do anything. So the cosecant of this angle right here that you have is the reverse of the sine. The sine would be negative radical 5 over 3, the opposite over hypotenuse. But I'm going to do the cosecant, so it'd be 3 over negative radical 5, which I would rationalize into 3 radical 5 over 5 with a negative. All right, sorry, that's so ugly. All right, so the next one's secant. A secant, and I would draw an angle at the point negative 4, 3. So go back 4 and up 3, put me about here. Draw my triangle down, right angle. So when you draw these triangles, it's kind of like a little bow tie in a way. Your little triangles, oops, oh my God. Your triangles are like right here. these 4 little areas. And so that's the only triangles that you're going to draw, and then you have the measurements of the sides based on the angles, on the point that you're given. All right, so I've gone back 4 and up 3. So this is a 3, 4, 5 triangle. Remember that hypotenuse is never negative. So the secant is the reverse of the cosine. The cosine would be -4/5, so I'm going to say -5/4. All right, and the last one, I want the cosine of this. So I have an angle with the ending point at -11 and -2. So back 11 and down 2. So there I am. So -11 and -2. Do my Pythagorean theorem. 11 squared is 121. 2 squared is 4. So I get the square root of 125 for that third side. Well, 125, let's see, that's 25 times 5. So it's going to be 5 radical 5. Alrighty. So my cosine is my adjacent over my hypotenuse. Remember, this is my angle that I'm doing. So my adjacent is -11, and my hypotenuse is 5 radical 5. So if I rationalize that, -11 over 5 radical 5, I get -11 radical 5 over, let's see, 25. And that would be my final answer for that one. All right, so it's your job now to do your worksheet for homework, and that is it. Bye-bye.